Hi, can everybody hear me? No. Okay. Hi, guys. It's so nice being here. Sorry for the delay. Very excited being here, honestly speaking, and happy to present a data engineering, maybe a little bit pipeline-centric talk. Um, Let me start by letting you know that I would love to first clarify where data engineering stands between teams and between technologies, and because as it appears, a lot of personnel or people, or maybe not just juniors, but people in bigger positions end up questioning what data engineering is. And there used to be a lot of misunderstanding and a lot of confusion uh, where it comes, where it comes to be. What does it do, and where does it stand between other technologies and other teams? And honestly, it's actually it's in between a lot of teams, and it's better be clarified before we get into um, more details. Here we go. So first of all, right, I would, I'd say, the clarification would start by, obviously, the main responsibility is, making sure that you have an ecosystem that is easily accessible, sorry, and optimized, right? That would be like the one-liner kind of thing when you ask about what a data engineer would do, right? But then it's the bigger the company gets, it gets a little bit more complex. What does that really mean, right? And then when it gets to be a little bit more complex, it ends up needing a little bit more of partitioning and understanding where that goes. And for that extent, I'd like to make sure that we all have the same picture as far as uh, the kind of data engineering people, or the data engineers people, responsibilities would go. And in that form, so there are the generalists, right? And then those generalist data engineers would really be perfect for the small teams, kind of, or small companies, kind of. They have a lot of skills. They have a lot of, high ground, or high understanding of different technologies, but not really in depth of knowledge of different system architectures or what the system architecture of that company is, in depth at least, right? But then in a little bit bigger company, right, mid-sized per se, there would be a pipeline-centric engineer whose main responsibility is to, feed and communicate with different teams, and then feed them the data they need. And when we say feed them, then we're talking about sources existing, and then we have to think about how to get the sources up to the layer where it's accessible for each team per se, right? Um, I hope you guys can keep hearing me, because it's a little confusing when I don't hear any feedback.
هاي زينب I'm sorry أنا سامعينك كويس. الناس بس بتطلب منك تعملي السكرين البرزنتيشن فول سكرين عشان يشوفوا.
Oh, sure. Okay. Thank you. All right. So going a little bit further than the pipeline-centric engineers, in a little bit bigger even company, right? There would be database-centric engineers, where, the focus is actually building different databases that already are, a result of smaller databases from smaller sources, and then having the focus of architecting that database for other users down the line comes off centric. But then this comes in a really bigger companies, right? Yeah. So that being said, right, a data engineer, I would need to have a lot in his pocket, right, or a lot in her pocket, and that comes with databases, different knowledge, right, data processing, different knowledge, programming languages, parallel processing understanding, distributed systems, definitely when it comes when the team gets bigger, and definitely a decent understanding of data science and machine learning. And the reason why this is actually important will come as we go forward and as we move forward into the actual examples and where each of those would take place, right? And definitely, apart from the technologies and relevant knowledge we would be talking about, there would be what kind of, maybe I wouldn't say just talents, but I would say what kind of qualities you would want to have, right? You need to be very organized in your mind, because then what you're actually doing is getting everything organized for different teams without when you do it right, they shouldn't be noticing that there is any effort being done. You know what I mean? So you need to be very organized, you need to have a very sharp thinking, and be very good at communicating with other teams. And definitely, consistently having critical thinking, because believe it or not, people end up either having more requirements that they didn't plan for. And by people, I mean the teams that are actually end up being your own client as a data engineer, right? So you consistently need to have a critical thinking to expect what might become an issue if they reverted to this or to that, or decided to be directed to this or to that. And of course, there is a certain margin or range of error we're talking about. Now, and that being said, given that, again, we've said a data engineer would be dealing with different teams and really supplying them with all the needs so that they can keep working, I'd like to make sure that we all, at this point, think of it as a machine and cogs, right? Every other cog.
Sorry to interrupt you, بس على الفيد الشات يعني في ناس كتير بتقول ال presentation is stuck. So can you stop presenting and share again?
طيب انا دلوقتي لو عملت اي غلطه في الكود حتى اوتوميتد تيستنج، حتى عامل كذا حاجه في البايب لاين بتاعي، انا ممكن اديبلوي حاجه تفيل فيها حاجه فيها بلاش حتى بقى، يمكن انا بديبلوي مثلا فيتشر جديده
هي كده غيرت في الاخر
مثلا الناس مش عاجباها خالص، بوظت الدنيا، بطأت الموقع جدا، بطأت
Okay, guys, I hope the screen is a little bit better now.
It is working, just ممكن تحطيها full screen.
It is full screen, it might be a network thing, but it's currently full screen. Okay. So I'd like to think of this as a machine and cogs, right? Each single team is a very important cog to the whole machine, right? But then without the main machine, without the belts around it, they wouldn't turn, they wouldn't move. And in that case, it's either the machine not getting any specific results, right? Because there are no cogs doing something, or the cogs aren't moving around and aren't producing any without that machine. And with that metaphor, of course, data engineers are the machine. Now, let's get into a little bit more detailed about how pipeline thought might go, right? And how does a layered thinking takes place into that, and how important is it, right? Because before we go into that specific example, let me say the following. There are two kinds of pipelines we would go through. the first type is a pipeline that has to do with serving a team, right? So you would be dealing with the data from the application starting point up to that team, right? And then there's a different set of pipelines which actually help the procedure within a certain team, right? And we will see the differences in a bit, right? So let's start with the following, right? We have a very simple example of Kareem-like or Uber-like or Lyft-like application. And from that simple explanation, it would at least mean a mobile app for a user, right? A mobile app for a driver, and a server, right? Where requests go from users to drivers and handle all other details like updating payment information, like getting an updated service rating and so forth, right? Now, if we look a little bit further into that, we will see that from an eye of a data engineer, would be trying to focus on the following, right? We'd be trying to focus on, you know what? This means the database that backs your main app has to be there, right? That contains user and driver information as a starting point. And then there's a server of analytics logs, right? That serve, that have access to logs, which contain the request made to the server from the app, and then server error logs, right? Which contains the server-side errors generated by your app. Now, there's also app analytics logs, on the other hand, right? Which then app event logs or app error logs, each containing, either the errors in the app or the payment information and so forth. And then there is the ride database, correct? And then in that case, information about a single ride for user-driver pair and contains status on the ride. And then there is a customer service database. This contains information about the customer interaction and by the customer service agents. And might include all other things like voice transcripts, email logs, and messages, and so forth. Now, the point is, you went from a simple architecture as far as the application intent goes, right, into a more detailed separating the data stores from each other, right, thinking that, I will be needing those later. And if I try and get those all together into one from a starting point, I won't have the flexibility and the easiness of playing around with it later, right? So the first thing is, let's make sure we lay it all on the ground, architecting each of the data stores alone, right? But now that we have this view and then we see how it just evolved into separate parts and so forth, a data scientist would come. But now we have served. First of all, we have served more or less the data store need, right, for the application. But we haven't yet served a specific team by giving them an actual what's it called, and delivering them an actual data with the way they would want it, right? We haven't gone there yet. So mostly these teams are machine learning teams, right? Or AI teams or DS teams, right? And that being said, I would say if it's a DS team, which is in most of the cases in bigger companies, the data engineering starts to make sure data is flowing properly from applications to applications, and then mainly afterwards to DS teams, right? And in that case, there was a very important need to make sure that there is a layered thought, right? A layered thinking and a layered thought that is organized and we can go through in order to keep building different pipelines to different DS teams according to the need, right? Great. So ingesting the mobile app logs as we went through, server logs in real time, right? Those kind of things can come in ask for from a from a DS team who's saying, you know what, now that we have this, very nicely laid out application, I would like to correlate, first of all, see what are the actions that those users are doing on the app. And then I'd like to correlate those who pay the most in my app to those actions, right? And then I would later want to maybe forecast the action, right? So that, apologies guys, a second. Hi, Gamal. Hello. I'm sorry the screen keeps freezing. I will try and keep, the screen off and on to get it back into working. I apologize for that. I'll try to, explain it at least as much as I can so that those who would see the screen freezing would still be able to understand the content. I apologize for that. Let me try this one more time. I will share the whole screen and get it back again. Apologies again, guys. Okay, I sincerely hope that you see the screen shared right now.
شغالة دلوقتي وشايفينك في الكاميرا والفول سكرين I think it's good to go.
Okay, great. Let's go back to our example. Now that we have laid out the different databases, right? And we have laid out the application, let's quickly have a look at what one of the teams who are supposed to be a client to a data engineer might ask for, right? And that being said, it could possibly be a simply, what's it called, a software, and ask about, correlating actions of a certain app, right, to a behavior of the user, and then taking that and correlating it to those who pay the most, right? So that maybe later they will be able to forecast some other information, right? And that being said, directly that reflects to a data engineer to gather information from those different databases, correct? And then deal with those as a source of data to start building a pipeline, right, that serve a specific feature that the data science will start being working for. And before doing that kind of pipeline or building that pipeline, one of the asks of a data engineer would be to take into consideration the thousands or maybe millions of users, right, of logs, of users creating logs into an app, through an app, right, which brings the need of a distributed systems kind of knowledge, because then you will be looking at different servers and different factors involved, from which you're going to do some effort to start taking and taking in some of that source or original raw data, we might say, right, at this point. And then having done so, now the pipeline-centric work starts taking place in order to eventually give the team what they really needed, right? And in that effort, the layered thinking is very important, because now you have source data, right? And then and since we're going to be serving a data science engineer or machine learning engineer, we would start calling it source data models, right? And those data models are as raw as it can get, right? It might have been in databases already, and it might have been typed already, data typed already, or it might just been raw data. Somehow it was just through files and sheets, right? Whatever the manner the raw data was, let's agree on something. It's something that we have always to think about as completely immutable. However you get the raw data, right, you do not get to play with it. You do not get to change it or rewrite it, right? You just get to take it and then take it from there and see what comes next, right? And has it happened to be already typed? Great, we can skip some of the layers that we're going to get through. Has it not been typed already? Then we will just have to go through a couple other layers, right? Now, assuming it was very raw, was not typed, we would go through an intermediate layer where it's really about taking the raw data as is and just making sure that we get it at data type. And by data typed, I mean simply exactly the same, but changing this string raw format into an actual format that reflects the data, which is, for example, a date, which is an integer, which is whatever it is. You just have to start to put a type to it, right? And then having that, you would get to a next layer, which is really start getting points together and maybe doing some union to the different data points, right? And then making it in a shape that sounds like this is an actual primary layer that you can start working with down the line for any feature needed. Okay? Now, having that in place, now we start thinking about the feature specific that this team had asked for, right? And then this means that the next coming layer is really skewed into that specific feature. So for example, we would start be having or storing down a specific feature points from the data we've got according to a specific dimension that has been chosen and had been the goal that been decided by that team, right? And the reason behind doing it that way, because now you were able to get through different layers that had to be done anyway, and then got to a layer that is feature based, so that now at this point we can start organizing the different features and having specific model for each feature, and each only looking at the specific points that you care about through a specific dimension. And by dimension, I mean a goal, right? Because from a data science perspective, or wearing a data science hat, I would want to look at a specific dimension, meaning, for example, a dimension could be, a user worth, right? Or a user folding, or a user buying more. It's just one specific dimension, one specific goal, and then I would be choosing the independent variables that has to do with that specific feature, and making sure that these are very well stored in a way that could be easily accessed later on, right? And then becomes the part of model input. And from a data science perspective, you know what? It's great work that now we have the feature table. Now I want a way to be able to, ingest those into my actual machine learning models, right? And then it has a lot of names, different technology providers have different different names to it. Most of them call it a master feature as it's written. But it's at the end of the day, it does the same thing, right? It just added in the format that is exactly needed to keep feeding a specific model. And why is that important to a data engineer? Because at a big enough company that have a continuous feeding to its model, it's important to have a way that is sustainable, easy maintainable for a continuous results to keep coming out as long as there's a continuous feed. And that being said, of course, the format by which it's stored is very important. And then finally, the model output, of course, and then we would be looking into how to get that saved, right? And if there are different models, how to get these saved, right? And then afterwards, you would be looking at some stuff like, you know what, we could use this layer for reporting, we could use that layer for different reporting, etc. But the point is the layered kind of thinking, right? Because then you can make use of the same processes for different needs or the same parts of the data for different reporting and stats-related algorithms. Now, as we mentioned at the very beginning, right? We mentioned some technologies and we said those were important for a data engineer, right? But now that we've gone through, this example and we've gone through that example, I hope it's been a little, just clearer, right? Why were these important? Because as we go through, we had already gone through architecting a data store. We had gone through, a question of how would an immense or a huge amount of data could be distributed through different systems, and hence the distributed systems is concerned, right? And then data processing, right, which comes from one layer to another by default. And then programming languages is important because you either have to build the ATLs that are going to be needed from one to another, or perhaps just the number of bits that each type might be needing at some point, right? And then the migration and integration also comes within the same layers from one layer to another. And then, of course, the data science and ML knowledge is really important because eventually, the bigger the company gets, they become the more and more important client that a data engineer could have. And hence, most of their calls or most of their needs are intact with what they do. And if they don't understand what they do, then there might be some processes that could be enhanced. I hope that I clarified that bit. And finally, I would just I would like to shed some focus on not every data engineer has to have worked with all the frameworks, but every data engineer has to understand what a layered thinking is, because eventually you can make everything work without existing frameworks, and you might be stronger if you know how to use frameworks, but just don't depend on them as if that's what a data engineer is. It's never about the using existing frameworks. It's about the concept, and then you can satisfy that concept with existing frameworks, and that would be great. You know what I mean? And then parallel programming and parallel processing is really huge for what comes next, because the more you get into it, the more you will find out that in order to be super optimized, in order to be super efficient, in order to be super fast, things cannot go sequentially anymore. And that's for a fact is the main concept that a lot of frameworks have started to work with, right? In terms of maybe underneath technologies, underneath servers and workers and so forth. But again, don't go directly to existing frameworks, but understand the main concepts first. Yeah, and then the deeper you get into DAS needs, the better it would be serving it, that's for sure. I apologize about any of the inconvenience about the presentation being stuck, and I hope I was able to get all the content within time. And yeah, I am sincerely yours. Thank you guys very much. Guys, I'm happy to receive any questions.
Thank you, Zeinab. It was awesome. Let's take like a minute to read the comments and the questions. Okay.
I'm sorry. Yeah, should I expect questions, Fatma?
I'm just checking. Someone is asking he wants a roadmap for newcomers.
Definitely. But in that case, I would write a list, and would I be able to maybe communicate it to people somewhere through the platform, or I wouldn't be able to do that?
Yeah, sure. You can share it with me, or we can share it with the attendees through this event, or maybe after the event.
Okay.
Okay, let's have another look at the chat. Someone is asking, can you share the presentation with us?
Yes, definitely. Again, is there a way to share it through the platform?
I think, yeah, you can just share it with us as organizers, and we'll take it from there.
Okay.
Will the session be recorded? Yes, the session will be recorded. However, it takes some time for editing and will be posted later. I'm just going quickly through the chat. Okay, most of the chat was about the screen freeze. Okay, we can skip that. Okay, I think we're done. So thank you, Zeinab. That was really helpful, and happy to have you.
Thank you so much. So I can see some questions on the side, and
yeah, I went through them. Yeah.
Yeah.
Did you see other questions that I missed?
Yeah, the Kafka for junior data engineer is mandatory. No, it is not mandatory. It does have a lot of interesting concepts, and it's important to understand these concepts. But Kafka as a technology on its own, it's not mandatory. I wouldn't say it's mandatory. I can definitely share the presentation with you. I will be sharing with the organizers, and they will be sharing it with you. And I will do the same for junior data engineer skills needed. Muhammad Nabil is asking AWS or Azure or GCP. I would say, Muhammad, I always would like to go with AWS but it's not necessarily always the way to go. It really depends on what you're looking for. The least cost, the perfect, the perfect speed. At the end of the day, it's really a balance. I tend to always go with AWS as a personal preference, but that doesn't mean it's always the best, to be honest. Is data engineer a part of data science journey, or it's related to data architect? No, data engineer is not necessarily a part of data science journey. So you could be a data scientist without having to go through through a data engineering path, and the opposite as well. It is related to data architect per se, and it isn't mandatory to be a data engineer before you be a data science. How much Aran is asking about the LinkedIn account, and yes, definitely I can. Fatma, would you help me knowing does the platform already have the LinkedIn account on it, right? Because I added that to the profile.
It should be, yeah. Let me double check, and if it doesn't, guys, you can check like later today. It will be updated.
Okay, great. Kafka is a good tech for real-time streaming. Okay, as data scientist, I have dealt with many data. I try to gather the data using API and make some transformation, then save it to database. Should I have more data engineering skills? Now, as a data scientist, you're using what you have easily in order to serve a certain goal. So, if you have data engineers or a data engineering team, then perhaps they could do, better work regarding the pipeline and how they can best optimize it for you. But as far as the data science is concerned, no, I would say what you've done is good. But you can always have better knowledge of data engineering, because at some point, if you end up doing a lot of work with a less experienced data engineers team, you might be the one having to direct them, and in that case, definitely more skills would help a lot. That's from Muhammad Yassin. I hope that helped. Excuse me, I came late. Is there vacancies for AI ML engineers? Yeah, always is. Fatma, can we have do people send their CVs, for example, and then we can have somebody from HR looking at them and so forth?
We'll arrange it with them.
Okay. Opportunities for a junior data engineer on your team. Definitely there are opportunities, and yeah, same goes or for the vacancies question, and we'll organize it with the management team here. If you could communicate with the management team, that would be great. What approach are you recommending for saving intermediate layers of data? What level of data engineering knowledge would you recommend for a data science? What approach are you recommending for saving intermediate layers of data? I would honestly go with a typed what's it called, a Parquet file, Apache Parquet files, right? It's almost raw. It's also typed. It also doesn't take too much space. It's also very flexible to use in different ways. I would always go with that, but again, I would say a complete context is important to make a better decision. But generally, Reda, I think that would suffice the purpose, as long as you're planning to continue the rest of the layers and have other, and having some other plan down the road, right? That would be a good intermediate one at this point. I hope that answers your question, Reda. Shadi, what level of data engineering knowledge would you recommend for a data science? Actually, that's a very good question. And for that matter, I'm not sure how to reply to, the level of knowledge, kind of. But I would say a general understanding of how to save data in other format other than a straightforward database, right? And so good for ingesting it into your code. So, for example, understanding something like Python and a framework, that one of the frameworks that Python offers, right, in order to use the data in a simple way, yet optimized way, in order to make use of your data points. Not having to directly access databases at the very least. I'm not sure what level would that be, but then you would just have removed one of the main constraints of making your stuff work without having too many dependencies, right? Which is getting out of the bubble of having to access a database and writing back to a database. So understanding file streams, understanding file systems, understanding how to save data in formats somewhere other than being it locally, and somehow other than being it on a database would be good enough. How can I get internship in tech companies in data analytics? If you're an entry level and you could have a couple of courses understanding what that really is and writing those down in your CV in a manner that explains how what exactly the knowledge you have learned or gathered so far, we would be happy to either receive your CV, and also I'm quite sure that there are plenty of platforms that have this actual need, and so all you need is to get it through a platform for for CVs and so forth, which I think JobStack can also help with that. Ahmed Al-Gindi. Other Suleiman, thank you for sharing the CVs with Orange Innovation Egypt. Should there be another job with data science in marketing or accounting? Mina, I'm not sure I get your question. I'm sorry. Dunya Ahmed, how to start in data engineering field from data analysis field? Well, Dunya, so data analysis is really looking at the data and maybe visualizing it through some BI tools. If that was what you need, is what you mean by data analysis, then I would say you would not go from data analysis to data engineering, but rather you would start from understanding some of the coding main concepts, right? And then understanding some of the languages, understanding what is what's a type data and what's a non-type data, and then taking it from that point on. Rather than data analysis field, you know what I mean? So you would have to start from a more of a developer path rather than analytics path. I hope that helped. Is IBM certificate for data engineering enough for an entry-level position? Yes, it is. Definitely. Considering I'm shifting from another career path, yes, awesome. Should there be a strong background with data science or marketing or accounting? Should there be a strong background with data science? Oh, not necessarily, no. So data science on its own requires coding skills, and it requires mathematical skills in order to understand what the algorithms do, or how are they, how were they created in a way, and then understanding how does it work, and then so you would be able to play around with constants and configure it as such. So as far as marketing and accounting in specific, no, you wouldn't need those for a data science in general. As long as you're not talking about any specific industry where you want to apply data science to. I hope that answers your question, Mina. Muhammad Yassin, is there a remote internship for data scientist or junior ML as a medical student, and it's hard for me to work on site? I mean, I'm going to communicate with the management here about how to get the opportunities to you guys and how to show it to you, and make sure it's available. And if there is any such opportunity, we'll definitely be able to know.
If I may add, Zeinab, guys, you can visit Halan's booth on the main reception of this event. So just visit the booth and interact with the representative there. They will have more information about this.
Yes, as Fatma just mentioned, regarding the specific opportunities and perhaps even, submitting your CVs or something like that, it would be best if we could do it through the booth, which I think would be held tomorrow. Fatma? I believe so, yeah.
Sorry, I was on mute. No, actually, the booth is already up and running, so you can guys go ahead and interact right now.
Perfect.
The virtual
so you guys
booth,
can,
yeah. The virtual booth is up and running. You can interact now.
Perfect. So you guys can immediately do that. What about data camp, data engineering track is enough also? By what? Sorry, Muhammad Hasib. What do you mean by enough? Okay. So generally speaking, is it enough to start with? Yes. Is it enough? Meaning you would just stop learning from that point onward? I would always say you would always want to catch more, because data engineering is the one thing that is between every other team and is the one thing that interacts with every other technology. So it's good enough to start with. It's never good enough to stop at. I hope that answers your question. I think that's it, Fatma. Thank you guys very much for your time. I hope it was useful. Thank you guys. Bye-bye.